Hi, and welcome to Factors Affecting Solubility. This is kind of the meat of this unit. This is a very important topic having to do with why some things will dissolve and why some things won't. Also, amounts are kind of discussed as well. So you might have had the experience before of getting oil on your hands, grease or oil, or when you're washing dirty dishes. Sometimes when there's a lot of oil or grease involved, that kind of makes what you're doing a little bit more difficult. That's because those things aren't soluble in water. However, on the other hand, if you get something like sugar on your hand, it's very, very sticky. It's annoying, but it rinses off very quickly with some water. So the first thing we're going to talk about is why some things are soluble in water and some are not. A nice demo that you can do at home, you can pour into any glass container that you can see through, like just a clear glass. You can put some water in the bottom of it, and then a layer of oil on top. Oil is actually non-polar. Water and oil don't dissolve. You're always told that it's only because of their density. It's actually because water's polar and oil's non-polar. So they actually can't really interact with each other. Then you can go ahead and you can actually add some droplets of food coloring. So if you added just a couple droplets of red food coloring, they actually stay in these little circular conformations in the oil layer, but they will dissolve once they get down to the water layer. So what you can actually do, you can try this at home. It's really, really simple, and you can really observe how things dissolve based on molecular shape. Our solubility rule that is extremely important is like dissolves like. And this means that polar solvents, water for example, are going to dissolve polar solutes and ionic compounds, because those are things with charges, or with charged regions at least. Nonpolar solvents will only dissolve nonpolar solutes. So this is actually an extremely helpful rule that really kind of narrows down based on polarity what will dissolve and what will not. So keep in mind that water is polar. You should already know this by now. You should be familiar with its shape, its excess electrons, the fact that it's a little negative here, the fact that it's a little bit positive here. So there are a lot of implications of water's polarity on how it behaves. Specifically, water can interact. Molecules can interact with each other, form hydrogen bonds, attract ions, and they also have a high boiling point because of that formation of hydrogen bonds. Water likes to dissolve, as we mentioned, stuff that's ionic or other polar molecules. The reason for these is because there are charges that water can interact with. Ionic compounds are able to break apart or dissociate in aqueous solution because of water's polarity. These are some of the food dyes. I probably should have had this up here before. So when you're looking at why food coloring dissolves in water, we actually have little kind of polar regions on these molecules, little charged regions. You can see that for the most part they're fairly symmetric with the exception of blue 1. I don't think that's a great drawing of that structure, but these kind of charged regions right here are able to interact with water molecules. So it's a little bit positive up here. A little bit negative up here by the sulfur and oxygen. So actually a water molecule can have an interaction with that on the hydrogen end where it's a little bit positive. On the other hand, oil is pretty non-polar. It's a crazy looking molecule that I've got up here, but it doesn't have those charged regions. They can interact with water. They can interact with the food coloring. So factors affecting solubility include molecular identity. Whether or not something is going to dissolve in water is directly decided by interactions between the solute and the solvent. So the like dissolves like rule that we talked about a minute ago is extremely important here in determining whether or not something is going to dissolve in water. But like dissolves like means, as we mentioned before, nonpolar solvents can interact with polar stuff. Polar solvents can interact with polar molecules, and they can also interact with things that are ionic because ions have charges. So a little table to summarize this for you. Nonpolar solute, will dissolve nonpolar solvents, but won't dissolve polar solvents. Polar solutes will dissolve our polar solvents, in polar solvents, I should say, but won't dissolve in nonpolar solvents. And ionic will only dissolve in polar. There are some words that go with this. These are kind of a little bit beyond some of the Regents definitions you need to know. But when one liquid can dissolve in another, we call those two liquids miscible. When two liquids are not soluble in one another, such as oil and water, we call that immiscible. So an example of miscible liquids, if you mix some ammonia with some water or some hydrochloric acid with some water, they're miscible in each other. They will dissolve. It's extremely important to keep in mind that water is polar. So I just want to show you a couple of more visual examples of what happens with certain molecules. So water, as we mentioned, looks like this and has these nice charged regions. When a water sees a hexane, and if you remember, hexane is the stuff that we used in that penny lab that really evaporated super, super quickly. We'll do a couple other demos with this in class. So this stuff has very weak intermolecular forces. This is a polar molecule. When water shows up to the scene, it has no way of interacting with that hexane. It's kind of like if you meet somebody that's totally different from you and you don't think you have anything to talk to them about. Since we have that negative positive charges on water, they really don't have anything to attract to in the hexane molecule, so they just don't interact with each other. On the other hand, if we put water and ammonia together, what actually can happen here, we have this little bit of negative right here, ammonia, which is also polar, is like, hey, you know what? I got some hydrogens. And my hydrogens are a little bit positive. So these interactions, and you have another negative up here that could interact with another water. So you're actually going to have a force of attraction right here. You're going to have intermolecular forces, you're going to have interaction, attraction of different charges. Therefore, in this case, you're going to have solubility. They will dissolve one another. Water and salt. Any type of a salt or ionic compound that we talk about, this negative region by hydrogen, if we were talking about sodium chloride, could interact with a sodium ion. And that's actually how dissociation and dissolving occurs. Waters interact and surround ions. If we faced our molecule the other way, and then we had chlorine float up, because chlorine is negative, we would have an interaction with that positive charge on that hydrogen right there. So interactions are what allows for something to dissolve in something else. When we have charges, they're able to interact. Non-polar molecules actually interact in a slightly different way, but because none of them have charges, they're able to interact with one another. So solubility is how many grams of solute will dissolve in solution. There are things you can do to make something dissolve more quickly. You want something to dissolve fast. You're going to stir or agitate it. Okay? So when you're making Kool-Aid, something like that, you stir it. Or you shake it up. Agitate just means kind of physically shaking it or stirring it. If you want to dissolve a large clump of sugar, you would crush it into smaller pieces. So what you're doing here is you are increasing surface area. In other words, decreasing particle size. If you want sugar to dissolve quickly, you can do so if it's in smaller pieces. If we want to actually increase the number of grams, or the actual amount of something that is dissolving, we must increase the temperature. So So in a set solution, if you want to get more sugar to dissolve, you actually have to do so by increasing the temperature. If you stir and agitate, it'll make everything happen faster, but it won't actually affect your maximum number of grams. So that wraps up factors affecting solubility.